A pleasure to introduce Eric. Eric's a good friend and a colleague. We're both Lions fans. Neither of us bite kneecaps. He is going to be speaking to us. You guys may have heard of NYU Tron. And so Eric is the originator of that. And Eric will be speaking to us about the great work that he's been doing on that.
I do have some disclosures not relevant to this talk. And for the initial part of my talk, I have some slides on how existing kind of clinical registries work, and we've heard a lot about this from other speakers, so I'm not going to belabor these points. This is roughly the workflow of registries these days. Clinic visits, manual data entry, and we've heard this from the other speakers, and heard how wonderful this has been, but also some of the challenges in some of the other talks. Obviously, there's many registries, and of course, as we heard from Dr. Ash and the other speakers, there's a lot of very real-world benefits from running these registries in terms of the clinical care we provide to our patients, the post-market surveillance for our companies, and ideally, in many cases, registries are fueling innovation in spine surgery, which is partially why they've been adopted by so many of our societies. There's also this reality to implementing registries, which we've heard about from some of the other speakers as well. I think many of us feel like the character here, we just want answers. Which there's a lot of barriers to this. And we've heard about the cost, of how costly it can be, both in terms of time and money for these registries, as well as some of the things we haven't talked about as much in the other talks, how they're static. It's hard to modify registries after we've rolled them out. And then frequently they lack the real-world nuances of clinical care. And so these consequences and why we face these challenges with registries, I would like to suggest are directly stem from how we build them. Right? Because fundamentally we build them like this. We're trying to turn our patients into tables for statistics. And this basic construct, which underpins every single registry we do, fundamentally places limits on what we can do with them and the cost we have to put into building and maintaining them. And what I'd like to suggest in the rest of my talk are ways we can move away from this. In part is because our current registry systems, they're not built with AI tools in mind for downstream usage, and they're not built for AI tools to enter the data into them. So what we want to do, I think all of us in the coming years, is really rethink registries for and with AI. For the rest of my talk, I'm going to go through several studies which have come out in our literature over the past couple months to years, which I think hint at what this future reality will look like. In the future reality, I think we want it to look something like this. Asynchronous measurements obtained ideally in the real world from mobile devices, imaging, or in our clinics. They're automatically entered into the registry systems, they're processed by AI tools, and they deliver us those insights as they happen with our patients. This is the future, and the question is, how do we get there? And it's changing the basic infrastructure of registries. How the data is entered, how it's stored, how it's processed, then ultimately it's on us to change how it gets delivered into clinical care. So the first of these papers is from my friend John Yoon at UPenn. I think many of you are probably familiar with this study. It's one of my favorite studies of the use of mobile devices in spine surgery. And it's a very basic project. They took 14 patients, they gave them smartphones, and they recorded their step counts, which is a very basic measure of functional outcomes in spine surgery. Probably one of the most basic is step count. And their unsurprising conclusion, as you can see here in these very colorful figures, is you can see how patients did preoperatively, postoperatively. You can track their clinical course in terms of these normalized step counts. I would like to suggest, however, that there's one huge problem with the storage here, and it's normalized step count, right? We can imagine how this would get logged in one of our existing registries. Someone would go, pull this off a device, and enter it into a registry. But normalized step count is really basic. My question is, why aren't we storing the raw accelerometer signals? With the raw accelerometry data, we could derive the normalized step count in thousands of other measures. Or if you can get the accelerometers, you get the GPS, which is highly correlated with step count. You move more if you can walk more. And so rethinking what we store from mobile devices is part of this. Because if not, we're left with trying to guess what are the measures we do want to store based on the clinical literature. Step count, postural sway, it's time to get up and go. My lab actually did a big survey of the literature a few months ago, which we published in Neurosurgery, looking at all of the digital biomarkers across wearables and smartphones. And the question was simply, what is out there? What are the biomarkers out there? My big conclusion is that there are tons of digital biomarkers with no single great metric that's been rigorously validated. There's a million ways to slice the data, so why aren't we storing the data so we can slice it however we want after the fact? And this is what our registries should be building towards. Another project, obviously I'm talking about natural language processing, in our research, in our health system, is to use NLP technologies to build our registries from scratch. So right now, my lab can take my op notes and tell us simply, after I do a surgery, they can tell me where I place the implants, where the screws are, what approaches I used, and that's all automatically logged using natural language processing. Our prototype study, which we published, was done using simple regular expressions that were hand designed by me for my patients and by the other surgeons in our department for those patients. So simple incorporation of the surgeons into the engineering process using basic regular expressions allowed us to build this system. Nowadays, we use language models for a lot of this work. Again, my engineer, Shu Han, we have an entire system in place in our healthcare where our spine team employs an engineer who can help us access this data. This is the key employee for a spine team, I would suggest in the 21st century, a full-time data engineer. And then on the storage point, why would I want to log the levels I operate at, or have a RA log the levels that I operate at, the implants that I use, where I place my screws, when instead I could store my raw clinical notes and turn it into an engineering problem for Shu to solve? Rethinking how we store the data in registries. This is maybe a minor point. There's another project we looked at in federated learning. We wanted to learn from data across 5 major health systems, University of Michigan, Vanderbilt, Stanford, and Penn. And classically for this, everyone enters data, it gets logged into kind of some central registry or database. Instead, rather than that, we left the data at all the sites, and we trained a model across all the sites by moving the model between sites. And this is something we did. This didn't require a team of computer scientists. Our attending surgeons set this up at each site. The engineers at our team made something that was very simple, and they just copied it over off of their emails. We emailed it to them, installed it, and they could run the model. But again, this notion of decentralized registries and federated learning, many people have been talking about it. I think there are some maybe unique opportunities for this, but maybe not necessarily the case where we have shared data and common legal terms to make the data sharing possible. And last, but maybe not least, this idea of integrated AI across our health systems. We published this paper over the summer on building a language model that was trained on the entire data set of our health system, and then flexibly using it to process our operative notes. This is our current way of extracting data from my op notes or the other surgeon's op notes. This is a custom language model. But I think maybe more exciting, especially in the spine world where we care so much about imaging, is that once we have the tools in place, we record the raw data, the raw op notes, the raw imaging, all these dense data types in some database or some registry, suddenly we unlock the ability of these new AI models to process all of it. The same language model that reads all of our op notes can also look at my x-rays. And I think this is really this future of, by rethinking how we store the data, suddenly we can unlock new ways of processing the data with AI tools. So my vote is, let's rethink everything with AI when it comes to registries, how we acquire the data, how we enter it, how we process it, and ultimately the systems we use to analyze it and deliver care to our patients. It's not about the computers, it's about our patient care, but I really think rethinking registries is the first step in making big gains in this century into how we take care of our patients. Last but not least, this is my awesome lab, and we have time for questions.